Good afternoon. Now we have this second part, that questions from May 2017. Already we have solved two questions we have in first video, and now we are with second video. Again, I have clearly mentioned you have to see these videos to understand it very clearly. Now we have this one problem is from cantilever also, so you have to refer these also in this. And this loading diagram you have to go for. Already you have seen this in detail, which will explain your SFD and BMD concept. These videos are in mechanics of structure, strength of materials. Now we have this problem, draw shear force diagram and bending moment diagram of a simply supported beam as shown in figure. So now we have to find out value of VA and value of VB. So now we have moment about A equal to 0. And then we have 10 into 2 into 1. Then we have plus 30 into 2 minus VB into 4 plus 15 into 2. It will act at center. So this is 1 meter. So 2, 2, 4, 1, 5. So 15 into 2 into 5 equal to 0. And therefore we will get value of VB, that is equal to 20 plus 60, 80. 80 plus 150 divided by 4. So we have this value 57.5 kilonewtons. So we have 57.5 kilonewton. Then we have to find VA. So we will apply Fy0, and from this we will get it as VA minus 20, 10 into 2, minus 30 plus 57.5, and then minus 30 equal to 0. And from this we will get VA 80 minus 57.5, 22.5 kilonewtons. So now we will go to SFD BMD 22.5 and 57.5 kilonewtons. So we know shear force we have to find left and right of concentrated load and starting and end of UTL. So we are left of A 0, right of A 22.5 kilonewton, then left of D 22.5 minus 10 into 2. So we have 2.5 kilonewton. Right of D. So we have 2.5 minus 30. So it is minus 27.5. Then left of B minus 27.5 plus 57.5. So it is 30 kilonewton. And add, sorry. So left of B, we have only minus 77.5. So these are at right of B. Left of B will be as it is. And then right of B. In this we have minus 27.5 plus 57.5. And it will be 30. And at C, it is 0. And then we have to plot it. So we have 22.5 at A. D we have 2.5 and 27.5. Now it is again very clear. We have x to the power 0. So it is x to the power 1. No load between D to B. So we have horizontal line. Same as it is. Then B second value. So this is 27.5. Then we have another value 30, which will be plus, and then 0. So as it is x to the power 0, we have x to the power 1. Then we have to go to BMD. Then bending moment, we have to plot. So bending moment. Then we have bending moment. At A, we have 0. Then we have at D. Values we know, this is 22.5. So we can have this as 22.5 into 2 minus 10 into 2 into 1. And we have this value plus 25 kilonewton meter. Then we have at B. Now you can have choice. You can come from left. 22.5 into 4 minus 10 into 2 into 3 minus 30 into 2, and we will have this value equal to minus 30. If we will come from right side, then we have minus 15 into 2 into 1, because clockwise, so minus on right side. Then we will plot it. So we have 25 at D. Now this is x to the power 0, so it is x to the power 2 increasing, so slope decreases. At B, we have linear line because we do not have any load between D to B. And again at x to the power 0, that is for B to C. So we have in this way BMD, so you can see over here. So we have x to the power 0, then we have x to the power 1, we have x to the power 2. Here also no load, so x to the power 0, x to the power 1. Here we have x to the power 0, so x to the power 1, we have x to the power 2. So this is first problem, question 6, and we have second problem. Construct loading diagram. So we have asked only loading diagram. So we have these points we have marked A, C, D, E, B. So now we have two formulas already we have seen. One, if vertical line, we have reaction or concentrated load. Reaction or concentrated load for vertical line. And for linear line, we have UDL. Now at A, we have vertical line, so we have loading diagram. So we have at A, final shear force minus initial shear force. Final shear force we have 7.5. Initial we have 0. So we have 7.5 kilonewton plus means upward. So we can have this as upward 7.5. Then no load between A to C. Then we have at C, final shear force is 4.5 and the initial is minus 7.5, and we will get minus 3 kilonewton, means we have 3 kilonewton downward. So we have 3 kilonewton downward. Then till D we do not have anything. Then we have between D to E. Between D to E we have UDL. And we have final shear force 2.5 minus initial 4.5 upon span, and this comes minus 1 kilonewton per meter, means 1 kilonewton per meter, it is in downward. So we have 1 kilonewton per meter downward. Now no load between A to B. Now at B, We have final shear force 0, initial 2.5 kilonewton. So we have this as minus 2.5 and it shows 2.5 kilonewton downward. And then we have 2.5 kilonewton downward. Now you can see you have summation Fy03, 2.5, 5.5 and this 2, 7.5. We have to also check moment about A0. Then we can have 3 into 1 plus 1 into 2 into. So it will act at center. 1 into 2, this is 1 meter. So this is 1.5 and 1. So 1, 2, 3.5. And due to 2.5, we have again plus 2.5 into 5. And then we will get this value equal to 3 plus 7 plus 7.5. So we have 3 into 1 plus 2 into, we have 2 into 1, 2, 3, 3.57, 2 into 3.5 plus 2.5 into 5. It comes 22.5 kilonewton meter. It is clockwise. To balance it, we have to apply anti-clockwise 22.5 kilonewton meter. And now you can take moment about any point 0 and it comes 0, then we are correct. This is given SFD, ASFD kilonewton. So likewise, we have to draw a loading diagram. So this is all about your 2017 two problems we have in last video, and this video we are with two problems. I am going to upload videos on YouTube. You can refer from there. Thank you.